Alright, today we're going to look at trigonometric form of a complex number. Trigonometric form of a complex number. First of all, we know that Z equals A plus BI is a complex number. That can be represented as the point AB in a coordinate plane also known as the complex plane. The horizontal axis is called the real axis, and the vertical axis is called the imaginary axis. For example, if we look at the complex number 3 plus I, and we want to plot this, the horizontal is the real axis, the vertical is the imaginary axis. So we're going to go 3 on the x, and because this is I, the coefficient is 1, 1 on the imaginary unit. This represents the point 3, 1, or the number Z equals 3 plus I. Okay? So this number is how many we go left or right. This coefficient of I represents how many we go up or down. Okay? The absolute value of Z equals A plus BI is defined to be the square root of A squared plus B squared. Okay? So we square the real component of that number and the imaginary component. Notice it's A squared plus B squared. I is nowhere involved in finding the absolute value. So for example, if we want to find the absolute value of 3 plus I, it's the square root of 3 squared plus 1 squared, which is the square root of which is the square root of 10, 9 plus 1. So let's look at what the trigonometric form is. The trigonometric form of a complex number Z equals A plus BI is defined to be Z equals R times cosine theta plus I sine theta, where A is R cosine theta B is r sine theta, and r is the square root of a squared plus b squared. Okay? Because if we distribute this, we will have r cosine theta, which is a, and r sine theta, which is b, I. Okay? So that's a trigonometric form, and r is what? The absolute value. Defined to be the absolute value of that complex number. Okay? And we can find theta. Tangent theta is defined to be the ratio b over a. Okay? B over a. What? Tangent theta is b over a. That's a period. Look at an example. Let's find the trigonometric form of 1 plus 3i. We first need r. R is the square root of 1 squared plus 3 squared, which is the square root of 10. Let's find theta. Tangent theta is b over a. So if we do inverse tangent theta, we should get that theta is about 71.6 degrees. Okay? You can use degrees or radians. Just depends on what that tangent theta comes out to be. Had it been square root of 2, had it been 1 or something, we could have used just what? Pi over 4, you know. But nevertheless, this form is the square root of 10, which is r cosine theta plus I sine theta. We don't have to factor that out or anything? No. Okay. So we can find the trigonometric form of a number by finding r and finding theta and just substituting into this formula.
So whatever has to go as farther.
Now if it says just to find the trigonometric form, now we're going to do multiplication and division in a minute. Okay. So this we want to find the trigonometric form. What if we're given a number in trigonometric form and they want to find the standard form? Standard form is at a plus bi, but suppose we have 5 times cosine 135 degrees plus I sine 135 degrees. So we figure out cosine of 135 degrees is negative square root of 2 over 2. And sine of 135 degrees is positive square root of 2 over 2. And now, in order for this to be in its standard form, we need to do what? Distribute our 5. So we have negative 5 square root of 2 over 2 plus 5 square root over 2, square root of 2 over 2i. So we can go from one form to the other. Okay? With some problems, depending upon what the angle is, you may have to get a decimal approximation. Okay? You may have to get a decimal approximation if it's not one of our angles that's on our unit circle. And that's okay. You can have decimal approximations. So now let's look at the product and the quotient. How do we multiply and divide numbers in this trigonometric form? So let Z1 be some number, R1 cosine theta 1 plus I sine theta 1. And let Z2 be another complex number in trigonometric form. R2 cosine theta 2 plus I sine theta sub 2. Then I can find Z1 times Z2. It's going to be R1 times R2 times cosine theta 1 plus theta 2 plus I sine theta 1 plus theta 2. So what are we doing? We multiply the R's and we add what? The angles. You multiply the R's and you add the add the angle theta. To find the quotient, you divide the R's and then we're going to subtract the thetas. Okay? To multiply, you multiply the constants and add the angle. To divide, you divide the constants and subtract the angles. So suppose you have an example. Suppose you want to multiply 3/4 cosine pi over 3 plus I sine pi over 3. This is our first number. And we want to multiply it by the second number, 4. Cosine 3 pi over 4. Plus I sine 3 pi over 4. Okay? So what do? We multiply the constants. 3/4 times 4 is what? 3. And we do what? We add the angles. We have cosine of, what's pi over 3 plus 3 pi over 4? That's going to be the hardest thing, is finding what pi over 3 plus 3 pi over 4 is. It's going to be 13 pi over 12. Plus I sine 13 pi over 12. And that's the hardest thing. Adding those angles together pretty much is the hardest thing to do here. You multiply the coefficients and you add pi over 3 and 3 pi over 4. How do we divide? Suppose we have 2 cosine 120 degrees plus I sine 120 degrees divided by 4 cosine 40 degrees plus I sine 40 degrees. Well, we do what? Divide our constants. 2 divided by 4 is 1/2. And then we do what? We subtract. 120 minus 40 is what? 80. Okay? And that's all there is to this multiplying and dividing. You multiply your corresponding constants, add your angles when you're multiplying. When you're dividing, you divide your constants and do what? Subtract. This is this unit here. We'll start another unit next time.